This is Unit 2, Lesson 3. This is solving equations with like bases, in other words, same bases. This is your notes, pages 5 and 6. So sometimes we have problems where we still have one unknown in these problems. We don't have an x and a y in these problems either. We just have one unknown, x, and we might have two exponentials, one on each side. We might have an exponential on one side and then a number on the other side. We're also going to look at solving log equations too. But first thing we're going to start with is exponential equations, solving these when we have the same base or if we can make the bases the same. So the first step is check to see if the bases are the same. If they are not the same, then what we want to do is try to rewrite it so that they are the same. Now, the next thing we do is we cancel out the exponents if needed. Sorry, simplify the exponents. I was on the wrong line. Simplify the exponents if needed, and I'll show you what I mean by that. Then we cancel out the like bases. In other words, we just mark them out. Cancel out the like bases, set the powers equal to one another, and then solve for the variable. Now let me show you with an example what that looks like. Okay, so here we have 2 to the 2x plus 2 equals 2 to the 3x. So check to see if the bases are the same. They are. I have a 2 here and a 2 here. So if the bases are the same, I don't have to rewrite it. I don't have to simplify the exponents because I only have one base and exponent here and one base and exponent here. Let me show you one. This one right here. See, I have all threes here, but I have two on the same side that are multiplied times each other. So when we get to this one, I'll show you how to simplify those exponents. Let's go back to number 1. And what I can do here is cancel out the bases. When I say cancel out the bases, I mean mark them out. So mark out the 2's. And then what we can do is if the bases are the same, the exponents are equal to each other. So then what we do is we set up the exponents equal to each other and solve for x. So if I subtract 2x over here, I get 2 equals x. And that's it. X equals 2 is my answer. So here, excuse me, here I have two sides of an equation where the bases are equal again. So I can mark out the 5's. I don't know why I'm still on eraser. I'm trying to get a pen. Mark out the 5's. And if the bases are equal, the exponents are equal to each other. Be careful because I made the mistake of putting an x here the first time. So that's a negative x. Add 2x on that side. 3 equals x. Number 3, this time again I have 6's for the bases. They're equal. Negative 2a equals 2 minus 3a. Let's add a 3a over here. A equals 2. All right, those are really easy. Let's look at this one. If you remember, if you have like an x cubed times an x squared, you can combine these by adding the exponents together. So this would be x to the 5th. Same thing here. I have a base 3 and a base 3. They're multiplied times each other. So what that means is I can add these two exponents together. So 3 to the negative 2x plus 1 times 3 to the negative 2x minus 3 would be 3 to the, okay, so I'm going to add negative 2x and negative 2x. That's negative 4x. And then I'm going to add the 1 and the negative 3. That's minus 2. If you're not quite sure about that, here's what I did. I took one exponent and I combined it with the other exponent. So that was 4x minus 2. So I just added the like terms. And then the other side is just 3 to the negative x. My bases are the same. Cancel them out. Negative 4x minus 2 equals negative x. I'm going to add a 4x over here. X equals negative 2/3. You don't have to check your answer on these. So you might be wondering if you can solve these graphically. Remember how we were solving the ones from last week graphically? I think you can, but when I enter the 2 to the 2x plus 2 and the 2 to the 3x, I'm still looking for the intersection. It's probably way up here somewhere, but I don't know where it is, and it would be so hard to find it that it's actually easier just to solve it. I will tell you this though. once you get it to just the exponents, 2x plus 2 and 3x, you can enter that and find the point of intersection for those. If I can get this back zoomed in. The point of intersection for the exponents themselves, yeah, it's 2. So you could do that part, but you're still going to have to show me that you know how to solve these equations. So you can double check yourself on this by just entering the exponents when you get those bases isolated, or bases canceled out, sorry. Okay, number 5. So again, I have all 2's here. But on the left side, I don't have a base and an exponent isolated. So I need to combine my like terms here. So this would be 2 to the negative 3p plus p, 2p, that is negative 1p. So once I have that, I can cross these out and set this up. Negative 1p equals 2p, and then when I add 1p over here, I get 0 equals 3p, and then divide by 3, p just equals 0. So it gets a little bit trickier because here we have different bases, but I recognize that 9 is 3 squared and 27 is 3 cubed, so I can rewrite it so that the bases are the same. First thing I think I'll do though is combine these two exponents, and that's going to be 9 to the negative 2x equals 27. And then I'm going to rewrite 9 as 3 squared. And when I do that, the squared goes here and it gets multiplied times the negative 2x. And then I'm going to rewrite this as 3 cubed. Okay, so then I have 3 to the negative 4x equals 3 cubed. And then I can cancel these. Negative 4x equals 3, divide by negative 4, x equals negative 3/4. So again, you can go over to Desmos and check this, but you could only check this part right here. You couldn't check all this up here. You wouldn't be able to find the point of intersection, so it's almost not worth it to do that. All right, number 7. Again, I have 2 different bases, but I recognize one as 4 to the 0 power, so I can change this right side to 4 to the 0 power and then cancel out the bases and set my exponents up equal to each other. X equals negative 3/2. Number 8, not sure what 3 to the what power is when I just look at this, but I can go into my calculator and figure out that 3 to the 5th power is 243. So I can rewrite that as 3 to the 5th power. Cancel out the 3's. So I'm going to subtract 1 here. Oops. X equals negative 2. These are really pretty easy once you figure out how to rewrite them with the common bases. All right, and I think, let's see, I have 2 more in this section that we're going to look at logarithms. I recognize 1/10 as 10 to the negative 1st power, and I can combine these 2 exponents. It's going to be negative 2x equals 10 to the negative 1. Cross them out. And the last one is number 10. So I have 3 different bases. I have 16, 4, and 2, but I can rewrite all of these with a common base of 2. So let's do that, and then we can combine these 2. We can't combine them yet. We have to have that common base first. So let's see, this is 2 to the 4th power times 2p minus 3. I could have gone ahead and done that, but just want to be careful. Times 2 squared times negative 2p equals 2 to the 4th. So I can go ahead and cross these out. I'm going to be adding these 2, so I can write that as 8p minus 12 plus negative 4p minus, oh, that's it, sorry, negative 4p and then that equals 4. So let's see, I'm going to combine the 8p and the negative 4p. A couple different ways we could have kind of gone about this, but that seems to have worked. P equals 4. All right, let's move on. Now we're going to look at logarithmic equations with like bases. So let's do our steps. Cancel out the logs. Step 1, set the material inside the parentheses equal to one another. So we don't have exponents on these, but the parts in the parentheses would be the exponents. So we set those equal to each other. And then solve for the variable. And on these, because we're going the other way around, we do have to check our answers. All right, number 1, we have 2 log base 10s, so we can just cancel out the log and then set up 5x equals 2x plus 9. Okay, let's check. We just have to do the math here just to make sure they match up. Log 15 equals log 15. And so those check out, and so my answer is x equals negative 3. Number 12, again, I have 2 log base 10s, so I can cancel the log and set both sides in parentheses equal to each other. Here's my check step. I plugged in the negative 1 and got log 11 equals log 11. So that one checked out. Number 13. I still have the same bases. It's log base 7, but it's still the same bases. So I still get to cross these out. Okay, and I'll put my check step up here. Okay, so this was my check step, and it did check out. So k equals 2 is the answer to this one. Okay, so number 14, I have log 3 and log 3. So, you know, what's going to happen is on a quiz or a test is you're going to have, these are going to be kind of mixed up. So you'll have some where you might be able to use same base, or you might not be able to. So you'll have to recognize it. All right, so I can set these parentheses up equal. And I get x equals 0. Okay, here's my check step if you want to check that out. It did check out, so the answer is x equals 0. So here we have two natural logs, and because they are both log base e, we can cross those out. An n squared on this one, so I need to move everything on one side. Okay, so I just moved the added 9n and added 2. So now this is a is 1, so all I have to do is just factor this thing. My factor pair for 14 is 7 and 2. Okay, so I'll check these both. And both of these check steps worked, so I have 2 solutions for this equation, -7 and -2. So I decided to try it again. So when we canceled out the natural log, we had x squared plus 12, and we had -9x plus 2. So I did graph both of those. One of them is really easy to see. You've got your point of intersection right here. -2 was one of the solutions that we got. The other one you kind of have to scroll up a little bit, but it's not too bad. It's right there. So -7. So you could, again, you could double check your work by checking graphically as well. So I believe this is the last one. It is. We have a natural log again. Mark those out. Have a fraction over here, so I'm going to make this a fraction because I'm going to use cross products. Let's see, I'm going to do that x minus 5 times 5. That's going to be, I don't know what's happening with my screen. 5x minus 25 equals x minus 3. Subtract x there. 4x equals, that's going to be 22. X is going to equal 22 over 4 or 11 halves. You could also say x equals 5.5, 5.5. All right, so I'm going to go over to Desmos and look at this one too. Well, looky there. Okay, so I have my, don't forget if you have something like this and you need the whole thing to be in the numerator, put it in parentheses. X minus 3 over x minus 5 is this graph right here. This is a rational function. And then f of x equals 5 is here, and my solution, my x point is 5.5, which is what we got over here. So we could double check our work. All right, I think that's it. That was a really short video. I hope you found that pretty simple. I think it's a lot easier than the first 2 lessons. Don't forget that tomorrow we will do a quiz review, and on Monday you will have a quiz on the first 3 lessons.